Good.
Okay, so is this review material for your semester final?
No, this was just a quiz that we took, and I totally screwed it up.
Okay,
The last picture I sent you was the first part of this,
okay,
because that's the bonus.
let's go.
But I sent you the, yeah, this stuff. I don't need the top one.
The top one?
Yeah, no, the top one I got, I just totally forgot how to do it, so I know how to do it now.
So which one are we,
Just,
which one do we want to do? 13?
yeah.
Okay. So the average speed over the first 5 seconds. Average speed is an algebra problem, not a calculus problem. Okay? Even though you've kind of set it up like it's a calculus problem. That is the definition, the limit quotient definition for first derivative. Okay? What we want is the average speed, which is merely rise over run. So what do I want? I want 5 seconds, so I want f of 5. Now let's say s of 5 minus s of 0 all over 5 minus 0. In other words, average speed is slope. It's rise over run. That's all it is. Okay, and the rise is s evaluated at 5 seconds and minus s evaluated at 0 seconds. That's what the rise is. And the run is 5 minus 0. So, what is s of 5?
Is it 6.1 times 5?
Squared.
Yeah, squared.
6.1 times 25. So what is that? You have your calculator?
Yeah.
I bet it's 152.5.
Yeah.
So is this your writing over here?
Yeah, all that's mine. But I think what she meant by the arrows is I did what I needed for A or B.
Well, you did it on A and you should have done it on B. Exactly. Okay. But getting back, let's solve A. There is the S value when t is 5 minus the S value when t is 0. Well, that's 0. All over 5 minus 0. So that's the average speed right there. The speed that it's going to have at 5 seconds minus the speed that it had at 0 seconds, all divided by the run, which is 0 to 5 seconds. Now, let's look at B. What's the exact speed of the rock exactly 5 seconds after it was dropped? Well, we recognize speed as being velocity. It's not exactly the same. Velocity is a vector. Velocity has magnitude and direction, whereas speed is the absolute value of the velocity, just the absolute value of the magnitude. Okay? But that's okay. We can answer this by figuring out what velocity is. Well, if s is equal to 6.1 t squared, velocity is equal to first derivative of position, which is equal to the limit. You have not learned the power rule yet, is that correct? Not officially?
No.
Okay. So the limit of f of x plus h minus f of x all over h as h goes to 0. So that's what we have to do to this function. Now let's go through the math. So the way you solve these is, first of all, let's list f of x. F of x is 6.1 t squared. It's the same as s. Now what is f of x plus h?
Isn't it 6.1 parentheses 5 plus h?
Not 5. X plus h.
Oh, okay.
When we get the derivative, when we figure out what the velocity function is, then we can put in any time we want, and we'll get the velocity at that time. So let's not restrict ourselves in putting the 5 in yet. Okay, let's use this limit quotient definition right there. You've learned that, correct? Yeah. I'm sure you have, otherwise you wouldn't have written that there. And this is, I've written this wrong. This is actually t. The original function has to be a function of t, and so this is f of t plus h.
Right.
So now let's plug in everything. So we've got the limit as h goes to 0. Tell me what to write.
What do you want it?
What is f of t plus h?
It's just 5 plus h. So
no,
should I put 6.1?
Where the 5 isn't entering into it yet.
Okay.
We're not going to do it like that. Okay? That is one way to do it, but that's not the best way to do it. The best way to do it is to come up with the velocity function. In other words, let's not plug in our 5 seconds yet until we come up with the answer. Then we'll plug in 5 seconds and we'll know exact velocity at 5 seconds, or the exact velocity at 3 seconds, or the exact velocity at 7.2 seconds. If you plug in the 5 now, we're only going to come up with the velocity at 5 seconds. It's far more robust to come up with the velocity function. So we've got a definition right here. What is f of t plus h? Right there, I've written it.
Yeah.
So we have to distribute that. We have to distribute the t. In other words, you have to square the t plus h. So I'll write the 6.1 and then square the t plus h for me.
T squared plus 2th plus h squared
minus f of t, which is just 6.1 t squared, all over h. Okay? Now let's distribute this. So this becomes 6.1 t squared plus 12.2 th plus 6.1 h squared. That's just multiplying that out. Minus 6.1 t squared all over h. Now let's simplify. And here's the thing. No matter what the original function was, everything that does not have an h in it is going to get canceled out. This 6.1 t squared gets canceled out with that negative 6.1 t squared. Notice that the only thing we have left in the numerator are terms with an h in it.
Yep.
So let's factor the h out. What is our new numerator? We're going to factor an h out. What do we got left?
12.2 t plus 6.1 h.
Now that h that's in the numerator is going to cancel with the h in the denominator, right?
Yep.
And that solves the ultimate problem, which is we don't know how to do 0 divided by 0. Well, we don't have 0 divided by 0 anymore. Now, what is the limit of this as h goes to 0?
Isn't it just 12.2 t?
Correct. Now, that's your velocity function. In other words, the velocity as a function of time is 12.2 t. Now, notice how powerful that is. If you want, their particular question says, what is v of 5? In other words, after 5 seconds, what is v of 5? 61 feet per second.
Right.
With me?
Yep.
And like I said, whenever you're doing this limit definition, and trust me, you'll only have to do it, I'm going to tell you the power rule because it's going to be helpful to you in checking your answers. If s is equal to 6.1 t squared, here's how the power rule. If I want s prime, first derivative, I take that exponent, I multiply it by the coefficient, and I subtract 1 from the exponent. That's how hard it is, right there. Gave me the same answer, right?
Yeah.
12.2 t. Only it took about 5 seconds to do it instead of 3 minutes. But the reason that this is going to help you is because if you to come up with something other than 12.2 t using the limit quotient definition, you will have known you made a mistake. Okay? If I say this, what's y prime by the power rule?
It would be 125.
Start with the exponent, multiply it by the coefficient.
So just 20
and then
x.
Subtract 1 from the exponent. Okay.
Oh, okay.
If I have a polynomial like this, now I apply the power rule to each part of it. So y prime, well, let's even add a constant. Okay, so y prime is going to be what by the power rule?
18x squared.
Plus what?
2x.
Just 2. Notice that when I subtract 1 from that exponent, I get x to the 0th, right?
Yeah.
Well, that's always 1. So whenever you apply the power rule to an x that its power is 1, the derivative is just the coefficient. And the derivative of all constants is 0. So this is your final answer. Again, notice how easy it is to use the power rule. And you can use it on negatives. What if I had this? Which is this, by the way, 1 over x squared. What's the derivative? That'd be a monster to do using the limit quotient definition. But using the power rule, it's minus 2x to the minus 3. Easy peasy.
Yeah.
So know how to use the power rule. It'll be the first thing you learn when you take calculus next year, after you get through limits again. and the limit quotient definition, then they teach you all the easy ways to come up with first derivative. And then they don't ever ask you to do the hard way ever again, because nobody does the hard way. Nobody. Everybody, there are 4 very simple rules for differential calculus that let you find the first derivative of any function you want to give me, no matter how complicated it is. If I apply those 4 rules, I can differentiate without using the limit quotient definition.
Yeah.
All right, so that takes care of 13A and B. Let's look at this bonus question, because it's really kind of easy, especially now that you know. Of course, I'm not quite sure that the teacher's going to let you get away with using just the power rule.
No, I doubt that.
But that's okay. We can go through doing this the hard way if you want, but the concept is what's important here. And I'll explain what I mean. At what point will this equation have a tangent line that is horizontal? Well, what is the slope of a horizontal tangent line?
0.
So they're actually saying, at what point is the first derivative going to be equal to 0? So that is what produces a horizontal tangent line. Remember what first derivative is. It is the slope of the tangent line. So let's differentiate this the easy way. And we'll go back and do it the hard way if you want, but let's first of all do it the easy way. I'm just teaching you the concept here is huge. In other words, this business of having the tangent line be horizontal is perhaps the most important principle in calculus, because that's where the minimums and maximums occur. If I have a function that's like that, if I want to know where this local extrema is, it's right there because it has a horizontal tangent line. Also there, also there, also right there. So each of those would be a local maximum or minimum. In other words, using this feature of finding out where the tangent line is horizontal is gigantic. So what's the first derivative equal to?
2x minus 5.
That's it. The 3 goes away. And now we're going to set that equal to 0. Solving it is a piece of cake. X equals 5 halves. That means when x is equal to 5 halves, the slope of the tangent line is going to be horizontal. This is a quadratic. Okay? It's a quadratic that goes up. Here's 5 halves right there. What they're saying is the vertex is going to be right there. That's where the tangent line has a horizontal slope at 5 halves. Now, do you want to go through the math of solving this using the limit quotient, or you want to cover some other problems instead?
We can cover other problems.
Okay. It's all about defining, this is f of x, and then knowing what f of x plus h is, and putting it together according to the definition. Okay? So it seems really hard to do, but it's not as hard as it looks. If you do a few of them, you'll kind of get the hang of it, doing it the hard way. I'm not talking about doing it the easy way. I'm talking about doing it the hard way. Which page do we want to look up next? The middle one?
Yeah, we can actually just look at the middle one.
Okay.
I think what I messed up on the middle one is I just screwed up on really simple math.
Well, that's
The
good.
first problem.
That's good and bad. I mean,
I forgot.
better than screwing up on the concept. If you lay out the equation correct and don't solve it correctly, that's one thing. but if you don't lay it out correctly, then being good at math doesn't help.
So then
your general formula is wrong. Let's correct that, because I can see what's going on here. There's a couple of formulas for first derivative. Okay?
Yeah.
This is the main one. Equals the limit of f of x plus h minus f of x. That's the rise. That's the rise. The run is x plus h minus x, which turns out to be just h. It's still rise over run, but we're doing it as h approaches 0. Okay? Now, there's another first derivative definition that you're getting confused with, I can see here by some of the things you've written, where if I want the first derivative at a point A, in other words, if I don't want the derivative function, but I actually want to just know the slope at a point A, then I could say it's equal to the limit of f of a minus f of x, as in the bottom is x minus a, and you're saying the limit as x approaches a. That's another way to do it. But this is not nearly as powerful, this second way, because it only gives you the slope at this point A. And I may have it backwards. It may be f of x minus f of a. I think it is. I think it's f of x minus f of a. I don't use this one ever. The reason I don't ever use it is because this one is so much more powerful. This one is more robust in that this gives you a function that you can then substitute a in for x and get the slope anywhere, no matter what a is. Whereas the second one, this only is going to give you the slope at a, nowhere else. So it's only going to answer your one very narrow question, and the math is just as hard. It's not any easier to do the math. So let's always use the top one, unless they specifically direct you to use the other one. This is always going to be the best one to use. And what I see in your work here is you're substituting that 3 in before solving for anything. Now, and the reason I also see the red writing on there, and the red writing indicates to me that she wants you to use this top definition, because she's got the limit as h is going to 0. If you're going to have the denominator be going to 0, then you have to use this definition.
Yeah.
Completely different than the other definition. The other definition is as x goes to a or c, whatever. So let's always use this definition. And now, let's start very, very easy, actually. Let's list f of x. What's f of x? In other words, we're going to need f of x, and we're going to need f of x plus h before we can do anything. So let's figure out what both of those things are. F of x is what?
X squared plus x.
What's f of x plus h?
Is it x plus h squared plus x plus h?
Correct. Now let's expand that, because part of this process is you always have to expand this. You can't simplify the numerator until I've expanded this f of x plus h. So let's expand it.
X squared plus xh
times
2x. Yeah.
This is why I said it's a good thing to have this memorized, because you have to do it so often.
Yeah.
If you have to sit and FOIL it and then simplify that, it's going to add 30 seconds every time you need to do an expansion of a binomial term. And that's no good. Okay? So, now that's my f of x plus h, right?
Yeah.
Well, now I need to subtract f of x. So over here, I'm subtracting an f of x, and I put it in parentheses because I need to. If I don't put the parentheses there, it's not going to work out right. It's a plus, right?
Yeah.
Okay. Now let's remove the parentheses and simplify. And remember what I said, every term that does not have h in it is going to disappear. If it doesn't, something's wrong. Or unless it's a constant. If there's a constant, it may survive. But all of your variables are going to go away. In other words, notice that that x squared disappears with that x squared, and that negative x cancels with that positive x. Now, factor everything out of the numerator.
So it's...
You factor an h out because every term's going to have an h in it.
So it's h, then 2x plus h plus 1.
Now, that cancels with that, and now what is that limit?
2x plus 1.
Correct. Now, what is at point 3? What is the slope of the tangent line at 3?
It's 7.
Correct. See how much easier it is if we have a derivative that is a function of x. Now I can figure out any point you want to give me, not just at point 3, but at any point. I can give you the slope at any point. Let's see, what else did this problem say? What is the slope of the tangent line to the curve at this point? All work must be shown. Okay, so here's all the work that I'm going to show. And then down here, I'm going to say the slope of the tangent line at the point 3 is 7. There's all my work. If you would have put nothing but what you see on this page, you would have gotten it perfect. No points deducted. And notice that the derivative we came up with, you can check by using the power rule. That's 2x plus 1.
All right.
And it's always got to be the same, exactly. If you come up with, in other words, let's say you forgot to put the 1 in there, and you came up with 2x. Well, now by knowing that the power rule, it's actually got to be 2x plus 1, that tells you made a mistake, and you need to go back and figure out where that 1 has to come from. And it came from when you factored an h out, it turned into a 1. All right. Yeah, where you went wrong here is confusing the two definitions that you've learned. And they may have even taught you the other one. What is how to figure out the slope at that point only. In other words, not to come up with the first derivative function, but to come up with just the slope at that point. There's another way to do it. But it's not a way that I even like to teach people because there's no reason to ever use it. So now that we have the slope of the tangent line, what is the equation of the tangent line at that point? And here is where it really is helpful to use point slope format. What's the general equation for point slope?
Y minus Y1 equals M times X minus X1?
Yeah, if you're ever unsure of that, divide both sides by this and you get slope equals rise over run. Right? Slope always has to be rise over run. So if you come up with anything else, in other words, if you made a mistake and did that, well, clearly slope is not rise over run now. But if I make it minus, now it is. That's the rise, that's the run. Okay? So what do we know? We know what about this so far? In other words, I got to fill in a y sub 1, an m, and an x sub 1.
You know the X point.
You know the slope.
And then,
we just figured out the slope.
Yeah, you know the slope and then the X.
Okay, so we know the slope and the X point. So the slope is 7. The X point is 3. And we're always filling in for the X sub 1 and the Y sub 1. Now what is Y sub 1? This is f of x. So what's the Y point when x is 3?
12.
Correct. So that's y sub 1. In other words, they didn't give us y sub 1. They made us figure it out. And that's frequently what they're going to do. And then that's your answer. That's it. That's the equation of the tangent line. Wow.
So I could just leave it like that?
Yes, and that's the right way to leave it. You don't necessarily always have to put it into y equal mx plus b format. That's slope-intercept format, but they didn't ask for that. If they would have said, give your answer in slope-intercept format, well then you have to do the algebra on this to solve for y. But as long as they just want the equation of the tangent line, well, everybody uses point-slope format because it's easiest. So when you use point-slope format, you end up with this equation. Y minus some number equals 7, or the slope times that. And you don't need to simplify that. That's perfectly fine. In fact, this is the preferred answer. Now, the next part is a total gift if you get this part correct. It's a little silly that she has counted so much. In other words, you lose 4 points here, and then you lose 4 more, or 8 on the next one?
8 more.
8 more? Are you kidding?
Yeah.
That's brutal. Because the answer is so easy. What's the relationship between the tangent line and the normal line?
Isn't it the inverse of the slope?
You got to do 2 things. You got to flip the slope and you got to change its sign. Always got to do 2 things. You can't just do one thing to come up with the slope of the normal. So I got a 1/7 minus 1/7. So the only difference in the answer, in other words, is changing that slope to minus 1/7. There's the equation of the normal. That's the normal, that's the tangent line.
So how would you show work for that?
You don't need to. Seriously.
Okay.
Seriously, even though she says show all work. Guarantee if you wrote that, you'd get full credit for it. Because there is no work. That's why I say that it's really unfair for her to take 8 points off there. Because there's no work. As long as you know the relationship between the slope of the tangent line and the slope of the normal, then the answers the problem itself, right? In other words, the only thing I did was change that to a negative 1/7 from 7. It's the only thing I did. So if you had to show some work, you could say something like slope of tangent is negative reciprocal of normal. There, that's all you need to say. Put that sentence and then put this answer. That's all it did. All I did was I took the slope of the tangent line and changed it to the negative reciprocal slope for the slope of the normal line. But everything else stays the same. It's the same point. In other words, what we had was we had a function like that, and we figured out, let me put a grid on this thing. We figured out that at point 3, we had a slope of about 7, right? Like that.
Yeah.
Well, the normal still goes through that same point because the tangent line, there's only one point where the tangent line touches the function. So the slope of the normal has to go through that same point which is 3, 12. So doing the equation of the normal is a one-step process. 2, you got to get the reciprocal of the slope and you got to change its sign. So it's a 2-step process. But that's it. None of the other equation, the rest of it changes.
All right.
And this is very, very typical. I can't tell you how many problems I've seen like this in the last 2 weeks from all my pre-calc students. First they ask you the slope of the tangent line, then they ask you the equation of the tangent line, then they ask you the equation of the normal line. And the easiest of all 3 is by far C, and then B, and then A. At least if they're making you do it the hard way, and they are, for some impossible reason that I do not understand and will never understand, and I vehemently disagree with it. I do not think calculus should be taught by forcing students to do the limit quotient definition to figure out first derivative. I could give you 4 very simple rules to figure out derivatives, and you'd be able to differentiate any function you can write with 4 simple rules. And it's relatively easy. The hardest part of all differential calculus is this stupid limit quotient definition. It's by far the hardest part. So maybe they teach it at the beginning to weed out people that shouldn't be taking calculus. Although I don't think so. If I'm going to teach you how to ski, I'm not dropping you on the vertical, the steepest slope to start with. I'm starting you out on the beginner slope. And then we're going to go to the medium slope, and then we're going to go to the expert slope. But I'm never just dropping you on the expert slope and say, do it. And if you can't do it, you shouldn't be skiing. Well, that's silly. But that's kind of what they do. And it's not just your school that's doing it. It is the Common Core curriculum to force all students to understand this. It's called the limit quotient definition of first derivative. So the whole country is having to do it, not just you or your school. But a lot of minds better than mine have stated the same objection, including Saul Kahn. Saul Kahn does not think this is the way calculus should be taught either. From Khan Academy.
Yeah, I know what you're talking about.
Yeah. All right, what else do we have here? Do we have any below this? No.
No, it was pretty much like this only page that screwed me, because the entire thing, the entire rest of the test was like 1 to 2 points per problem, and then this entire
how
page.
How unfair is that? Yeah. Especially since this is the hardest stuff. I mean, maybe as a bonus question, I wouldn't mind seeing that as a bonus question, but to make it worth 4 and 8 points is crazy.
No, the entire thing's worth all 4, 5 of those problems are worth 8 points.
Each?
Yeah.
Wow. Wow. All right. Before we go, since it's obvious that you're going to have to do slopes of tangent lines, I mean the hard way.
Yeah.
Let's look at one that is solved just a little differently than the way we've been doing it.
All right.
Let's find the derivative of this function based on the limit quotient definition. Okay, so here's the limit quotient definition. Limit of f of x plus h minus f of x, that's the rise. The run is h. And we're going to take it as h goes to 0. Okay, so what is f of x plus h?
It would be 1 over x plus h.
Yeah, it's always the same. Whatever is in the parentheses gets substituted for x, wherever you encounter x. It's that straightforward, okay?
Yeah.
Minus the function, which is 1 over x, all of it over h. Okay? So this is what we have to solve, is this limit as h goes to 0. Now, notice this is a little different. It's not so easy to cancel everything, or at least it isn't on first sight. But we know how to subtract those two fractions. How do we subtract those two fractions?
Find a common denominator.
What is it?
It would be x parentheses x plus h.
What goes here?
X.
What goes here?
X plus h.
And you do need to put that in parentheses. You need to add the parentheses, because I'm subtracting that whole thing.
Okay.
Okay? Now, that whole thing is being divided by h, right? Well,
yep.
Operate on the numerator. In other words, we now have a common denominator, so we can operate on the numerator. What are we left with in the numerator?
Negative h.
Correct. So here's what we now have, negative h over x times x plus h all over h. Now what? What is that equal to?
Would be...
Put a 1 under the bottom h, flip, and multiply.
Yeah, so it would just be negative 1 over x parentheses x plus h.
Okay. Now what is the limit of that as h goes to 0?
Just x squared.
Negative 1 over x squared.
Yeah, negative 1 over x squared.
Negative 1 over x squared. Well, notice if we use the power rule. First of all, I'm going to write that with a negative exponent, because when you're using the power rule, you want everything to have exponents, right? Because the exponent is where you start. Well, if I start by multiplying the exponent by the coefficient, I get negative, subtract 1 from the exponent, I get that. That is negative 1 over x squared. The same thing we got doing it the much harder way. But this was significantly different. To do this one, we had to find a common denominator in the numerator. It was not the same as any of the others we did. All the others we have done is all we did was expand the numerator. Well, I suppose you could look at this as expanding the numerator to get this.
Yeah.
So it's really the same. It's expanding the numerator and then see if you can get the h in the denominator to go away. And it does. In other words, the only problems you have in calculus are figuring out what 0 over 0 is, the limit of that. So the moment you can get it to a problem where it's no longer 0 over 0, you have your answer. And this is not 0 over 0 anymore.
Yeah.
And this limit quotient definition can get a little tricky if, say, your function is sine of x. Okay? Well, if I want to know what the derivative of sine of x is, it's going to be the sine of x plus h minus the sine of x all over h. Okay? Well, how do you think I expand that?
Would it just be sine of x plus sine of h?
No, you use the sum and difference identity. Remember what the sine of a plus b is. It's the sine of a cosine of b plus the sine of b cosine of a.
Okay.
So that's what it would be. It would be the sine of x cosine of h plus the sine of h cosine of x. And this is why your trig identities are so important, and they get more important as you get more into calculus. You better know your trig identities because you use them a lot all over h. And then what you do next is, I don't remember, to be honest with you. I don't. I happen to know that the derivative of sine is cosine, and they tell you that. In other words, they don't make you do this math because it's not that easy to figure out how to do that math. I use the sum and difference to get to this step. Oh, I know what I didn't do. I didn't subtract off sine of x. There we go. And that is going to make it a little easier because I can now factor out sine of x.
Oh, yeah. Can you?
Yeah.
Or can you factor out sine?
Well, no. I can factor out just sine of x. In other words, this is what I'm trying to take the limit of. Well, if I factor out sine of x, this is what I have. What's left over? Cosine of h plus
Sine of h.
plus the rest of it. You see how I did that step?
Oh, yeah.
In other words, I combined that, and then I factored it. And in fact, I didn't do it right. This is a minus sign.
Okay.
In other words, this bottom line should be the same as the top numerator. And I'm still dividing by h. Remember, when you first started, they gave you a problem that what is the limit of that as h goes to 0? Remember what the answer was?
Isn't it sine of h?
Well, they also gave you that. What is the sine of x over x? And that's 1.
Yeah.
But this top one is 0. In other words, if I have the cosine of x minus 1 all over x, that's going to go to 0. Okay, so it wipes out this whole part of the fraction, and what I'm really left with is just the right side of that over h. And now, as h goes to 0, that, this goes to 1. No, excuse me. I figured it out. This is the first time I ever worked through this problem like this. It's kind of interesting. I know what that is, right? As h goes to 0,
that's 1.
That's 1, which means the limit is cosine x. That's how the derivative of sine comes to be cosine.
That's a lot of work.
It is a lot of work. It's the first time I've ever done it using the limit quotient definition. Usually they just give you them and ask you to memorize them. The derivative of that's cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. It's actually pretty easy to memorize them. There's a pattern there if you didn't detect it. But the official way they got this, the way somebody figured out that the derivative of the sine was the cosine, was by doing it this harder way that I just took you through. But here's what it means. It's kind of a fascinating thing to think about. Here's the sine curve. What they're saying, here's the cosine curve. What they're saying is that the slopes of the sine curve, what's the slope right there? 1.
1. Yeah.
That's why the cosine of 0 starts out at 1. Well, by the time I get up here, what's the slope there?
0.
That's this point right here. That's where the cosine is equal to 0. And so forth and so on. In other words, if I drew the slopes, this entire curve, and I took the magnitude of those slopes, and I drew another curve below it, echoing the size of each of these slopes, I would have the cosine curve. Exactly.
Okay.
Okay. All right. Anything else you need to go over, Mitch? You good to go for today?
Yeah.
Now, we've checked your schedule the rest of the year, make sure it agrees with your finals and stuff. The only day is probably next week, isn't it? I got you down for an hour from 4 to 5 next Wednesday. Does that still work?
Yeah.
Talk to you then.
And then the week after, it's that Monday. Is it the Monday?
Yes, Monday at 6.
Yeah, because then I have...
final must be Tuesday?
Yeah, my final's Tuesday at like 7 o'clock.
At night or a.m.?
No, in the morning. In a.m.
Okay.
Yeah, so.
Might be better off doing this on Sunday. You know why? In other words, if you do it Monday night, you won't get a recording of it by the time you have to leave for school the next day. Whereas if you do it Sunday night, you will. But I don't know how valuable that is to you. So
I don't use the recording. Okay. I write down most of the stuff you're saying.
Okay, that's fine. No, I don't have any expectations of you using the recording. I thought that it could be helpful. You know, if it's really complicated stuff, like if I asked you right now to show me why the derivative of sine is cosine, I bet you'd want to review the recording.
Oh, yeah.
So it can be helpful if you're really dealing with really complicated stuff. But I'll leave that up to you. Maybe you feel like it's more helpful to have the tutoring session as close to the quiz as possible. A lot of kids seem to believe that they'll remember the material for 12 hours. They may not remember it for 24 hours. That kind of thinking.
Yeah.
which I don't really like, because I'd like to see you learn slow and steady so that you'll remember it for a week and a month and 3 months. All right.
Yeah. I'll talk to you about it next week and see.
Yeah, no pressure. I'm not going to try to force you to move it up at all. You do whatever you want. I was just kind of trying to warn you that you won't have access to the recording.
Yeah.
Okay. I'll talk to you next week.
All right.
All right, Mitch. Bye-bye.
Bye.